Thanks. Awesome. Thanks. Wow, there are a lot of you here. I'm probably going to say wow about 10 more times. Wow. Also, the lights are very bright. All right, we got a lot of awesome stuff to show you today, so let's get started. My name is Joseph Ona. I'm an engineer on the React team at Meta. In the past, I worked on Relay, which is our GraphQL data fetching library, as well as Skip, which was an experimental reactive programming language that we built at Meta. And the last few years, I've been working on React. I'm supposed to advance the slide now. So back before all those things, back in 2010, I was living in Japan, and I was working, I had my first full-time job as a web developer. And I was writing raw HTML, CSS, and jQuery. That's the only way I knew how to write JavaScript was jQuery at the time. And I'm pretty proud of my work at the time, considering that I was testing on Internet Explorer, not just Internet Explorer, but IE6. It was like one computer in the back of the office that had it, could still run IE6, and you had to FTP. Do y'all know what FTP is? Yeah, you had to FTP and then run over there and check it. Yeah, that's the old days, the dark ages. Thank you for laughing. Oh yeah, I got to use the clicker. This is gonna be, yeah, I'll get used to it by the second or third time I come up here. I'm the class clown in meetings, so just kind of setting expectations low. So anyway, testing on IE6, you can kind of imagine that it wasn't super easy to realize the full vision that our clients had for their sites. I think we did a really good job, and I'm proud of my work, but it was just always really hard to build something as great as what our clients were really hoping for. And I think that this really speaks to our goal with React, to make it easier for anyone to build great user experiences. Now, it sounds nice. What do we mean? Let's start with user experience, or UX. When we talk about user experience, we're talking about a few different things. The most basic is things like good design. But we also want our apps to do more. We want our apps to start up fast. We want users to be able to move through our apps quickly and with confidence. But more than that, we're all here in this room because we're user interface engineers. We care about building something great. Things like small animations, subtle design tweaks, and all the bits of craft and polish that go into taking a good app, and making it great. Now, we know that it's always been possible, in theory, to build a truly great app. But our goal is to make it easier, and not just a bit easier, but dramatically easier to build a really great experience. We want to make it so that anyone can build something great, whether you're a student, a hobbyist, a designer, a developer, whether you're a first-time developer like I was back in Japan, or an experienced engineer, whether you're a back-end engineer, a machine learning expert, just trying to quickly get something up to show your colleagues, whether you're working alone or in a giant organization or anywhere in between. This requires focusing on the developer experience. Again, it's always been possible to build something great, but it's usually so much work that we just focus on the basics and move on to the next task. So we want to lower the barrier to entry, not just for basic features, but for sophisticated UI, to help you build something amazing in the time you actually have. So, how are we doing on this goal? In today's keynote, we'll answer that question by looking at three things. First, we'll look at the state of the React ecosystem. Then, we'll look at the type of experiences you can build with React 19. And finally, we'll talk about what's next for React. To kick things off, here's Lauren Tan to talk about the state of React.
Thanks, Joe. I'm Lauren. I'm an engineer on the React team. And I'm so excited to be here. And it goes without saying that this conference wouldn't have been possible without all of you. It's so great to see all of you again, some of you for the first time, since our last virtual ReactConf in 2021, but this time in person. So I thought it'd be really interesting to take a look at how the React community has grown since then. So let's start by looking at how many times React gets downloaded a week. So in 2021, in the year of our last ReactConf, at its peak, React was downloaded 13.5 million times. And now, oh, I went too fast. Oh. All right. Yeah, 1 billion downloads. Very cool. In 2023, all of you NPM installed React more than 1 billion times, which is awesome. Much better than me at handling slides. So let's also take a look at the React DevTools. So back in 2019, Tomo shared that there were 1.8 million active users of the DevTools. But as of this month, we have more than double the amount of developers who currently have the React DevTools installed. Last year, there was also a Stack Overflow survey sharing that 63% of developers use JavaScript, 40.5% used React. But the number I'm most excited about is this one. 36% of people learn to code learning with React. And I think that goes to show how much all of you in the community have given back in the form of tutorials, videos, blog posts, and even libraries that make difficult things simple. And this is all really important because I'm sure all of you know how much fun and rewarding it is to build software. So the more we can do to bring in the future generation of React developers, the better. But who cares about numbers, right? There's way too many people to thank when it comes to how much all of you have given back to the React community. And there's so many of you, I couldn't fit you on this slide, so sorry about that. But the work all of you are doing to share what you've learned about React, making it accessible to a wide audience, and being welcoming to newcomers is why I'm so happy to be a part of this community. So seriously, thank you all for making React so awesome. I'm sharing all of these numbers because it's easy to see React as just a library, or an architecture, or an ecosystem. But really, it's a community. This is ReactConf, but there's been React conferences for communities in India, China, Miami, all over the world. And with people who've come to React with really vastly different experiences. So whether you've used React from the beginning or your journey is just starting, and whether you live in Las Vegas or in Paris, React lets us all create user interfaces together. And that's because, as Joe mentioned, React's long-term goal is to make it easier for anyone to build great user experiences. So this reminds me of my own journey into React. A few years after college, at my second job, having just learned JavaScript as a baby developer, I found myself being the first junior front-end developer of a startup. And when I joined, their app was this old-school server-rendered application with a dash of spaghetti code here and some jQuery over there. And I was somehow given the responsibility of picking a JavaScript framework to help modernize their architecture and make their site more interactive and easy to maintain. But as I did my research over a few weeks, I compared the options, and React's simplicity and composability really jumped out at me, because we needed something that was intuitive and easy to learn, but it would also scale with us as we grew. But as I did my research, I couldn't help but notice that there were a lot of loud voices on the internet telling me to reconsider. But as I built a small prototype in React, and I saw how intuitive it was to me, a noob, I was convinced that React was the future. And I'm happy to say that to this day, that's an actual picture, by the way, that startup uses a lot of the still uses a lot of the early infra that I helped them build. So React really did grow with them, so I made a good choice. I'm sharing this because a lot of you may have had a similar story in how you found React. But no matter your background, there's so many people like you and me in the community who saw something special in React, and we believed in it enough to bet our future on it. And that's why we're all here today. Along the way, many of you in the community have went on to make us all stronger by creating reusable libraries that build upon React's key features and primitives, and helped us innovate on new ways to make it easier to build great user experiences. So whether it's state management, charting, routing, UI libraries, there's a really good chance that there's a well-maintained React library out there that helps your app achieve its goals efficiently and with high quality. But that's a lot of choice, right? And yeah, sometimes it can be just way too much choice. And it can be really hard to make a decision about what to choose when you start an app. So this is why last year, we started recommending choosing a React framework. React frameworks handle many foundational features of an application for you, while still giving you a lot of flexibility in choosing additional libraries. We have several great speakers lined up over these next 2 days who will share more about these React frameworks, so please don't miss these talks. Now, all of these frameworks share something in common, and that is that they build on many of React's key features that we've developed over the years in our pursuit of making it easy to build great user experiences. So here's Joe to tell you more about those features.
Awesome job. Awesome job. Thanks, Lauren. Next, let's turn to React 19. Andrew and Josh will share more about what's in this release in just a moment. This release builds on the foundation of concurrent rendering that we established with React 18. So to put these features in context, it helps to understand how we got here and our approach to solving problems with React. So what makes UI so hard? Many of the most complex challenges in user interface development are really problems of coordination and scale. For example, synchronizing application state with our UI is a giant coordination problem. There's an exponential number of state transitions to consider. And our approach to problems like this in React is to turn these coordination problems into declarative APIs, like JSX, where you describe what should happen, and React manages the complex coordination on your behalf. We solve the scaling challenges by ensuring that our APIs compose. You can wrap one component in a larger component until you build up an entire app. Declarative, composable UI. Let's see a couple more examples. In 2019, Meta's UX research showed that users perceive sites as faster if our content loads all at once, rather than popping in individually as things are ready. But how do we know when everything's ready? That's a complex coordination challenge, coordinating all the data loading across the entire page. React Suspense is a declarative API that lets us describe what data we need and what loading states we're willing to show, and lets React do all that complex coordination to show those loading states appropriately. Suspense also incorporates the results of this UX research, balancing the desire to show content quickly with the need to show a complete experience. So by using Suspense, you can build a site that takes advantage of all this UX research out of the box. But these types of coordination and scaling challenges aren't just limited to the client. Some of our logic belongs on the server, and some of it needs to be shared between the server and the client. Server components make React's same declarative, composable approach to UI work seamlessly across the server and client, allowing us to have easy access to back-end data sources while also continuing to render interactivity where we need it. This lets developers continue to break down their applications into small, reusable pieces, regardless of where those pieces should live. In React 19, we're continuing to expand on this theme, solving more places that currently require complex coordination. To tell you more, here's Josh.
Hi, I'm Josh. I'm a member of the React team at Vercel. And today, Andrew and I are going to give you a sneak peek at some of the great features that are coming to you in the next major version of React. We're going to tell you about some improvements to server rendering and Suspense that simplify some tricky coordination problems with HTML. We're going to cover some long-anticipated improvements to hydration. We're going to talk about a new core concept in React we call actions. And finally, we're going to give you an update on some welcome changes to JSX. All right, let's begin. The React team takes special interest in solving problems that require coordination across an application. But data loading and UI states aren't the only aspects of an application that can benefit from built-in coordination. During the past couple years, I spent a good bit of my time digging into the challenges of HTML document ordering to make declarative composable HTML possible. Now, I know what you're thinking. That's kind of silly. React already allows you to write composable HTML, and that's true, but it's for visual content. But HTML conveys document metadata, scripts, style sheets, and preloading hints for fonts, images, and more. Imagine an app where some routes render articles. Our article component is a great place or natural place to put page-specific information, both the visual article content, but also things like the page title and the styles that are specific to the article's visual representation. But consider where these elements will end up in your HTML document if you were to actually render them like this. They're almost certainly not going to be where you want them to. The title is document metadata. That belongs in the head. The style sheet is deep within the document, and the browser can't start downloading it as early as it could, and will likely paint before loading the style sheet, and you'll end up with a visual bug called flash of unstyled content. This seemingly simple task of fully utilizing HTML from within a component isn't so straightforward. So let's see how we might solve it today. One sign of a good component is whether you can understand, one sign of good composition is whether you can understand a component's behavior without having to consider all of the other components in your application. We call this concept local reasoning. We can preserve local reasoning by using UseEffect or portals directly inside our article component to insert these tags into the document. But now we've lost these critical pieces of information in our server render. This is even worse than before because bots and other technologies that don't run client-side JavaScript are going to completely miss the title. And the style sheet's loaded even later, so the browser won't be able to discover it until React has hydrated. Really, the only viable path forward is to split our component up. We need our HTML to look like this, with our title and style sheet server rendered and in the document head. So we can provide these tags to the component responsible for rendering the head. But now we have another problem. We have to figure out how to get article-specific information into one of the most generic components in our entire application. We've thrown local reasoning out the window, and we have a complex coordination problem to solve. And whether you solve this problem yourself in your app or you use a library to handle it for you, this coordination is tricky to get right. So what would it look like if we had a React-powered solution for this problem? We started with the premise that this composition of HTML, this composing of our HTML was ideal for component composition. And we also said that this was ideal for our document composition. So in React 19, we set out to make it possible for you to have both. Solving document metadata isn't that complicated. You know, title tags, links, meta, they're typically only in the head anyways, and so we can just kind of ensure their position there when server rendering. And we just need to make sure that hydration can find them, even if they're not sort of inside the component where it would normally look. But style sheets are a bit more challenging. Style sheets are sensitive to their relative order because later style sheets override earlier ones when style rules conflict. For this, we need a little help from you. In React 19, if you tell React about the precedence of a style sheet, React will insert it into the document head, ordered relative to the other style sheets with a defined precedence. In this example, I have a list component, which renders a style sheet with a precedence that I chose to call default. Precedence is loosely modeled on CSS layers, where later values define higher importance. So now, when I render a style sheet in my article component with a precedence value of high, React will insert it after the style sheet found in my list. But now imagine I have a carousel component which renders a style sheet with the original precedence, default. React ensures that this style sheet is ordered alongside other style sheets with default precedence, even if it was discovered much later in the render. With precedence, React can safely reorder the style sheets to optimize their loading performance, but we still need one more thing to make these really composable. React understands that each style sheet needs to only be loaded once. So even if you have different components that all depend on the same style resource, or you render the same component multiple times, you won't end up with unwanted duplication. But relative order is only one part of the problem with style sheets. Earlier, I mentioned that browsers wait until all the style sheets in the head have loaded before doing the initial paint. This is a critical feature for browsers because it prevents pages from rendering unstyled content or flashing unstyled content on the initial load. But React isn't just about loading initial documents. With server streaming rendering, it might discover a style sheet late, long after the head tag has already been sent to the browser. And on the client, React can discover new style sheets on any update. If React is going to provide a useful capability with style sheets, we can't let flash of unstyled content bugs ruin the experience. So when you use the precedence prop, React will also ensure the style sheet is loaded before revealing the content of the nearest suspense boundary. You can think of this feature as suspense for CSS. Suspense for CSS works across server components, streaming server rendering, and the client, so you can confidently render your style sheets inside the components that depend on them. React 19 also adds support for hoisting and deduplicating async scripts, another HTML feature that has historically been hard to compose within components. And it also has support for preloads and other kinds of browser hints, with new APIs that can be used both during render and during user events like hover and click. Now, I can probably guess that many of you don't include these kinds of HTML tags or features directly into the components you write for your applications. And that makes sense. These features have historically been very hard to coordinate, and it often took the power of a dedicated library or a bundler to make this feasible. And that's okay. We expect the earliest adopters of these new features to be libraries and bundlers that can remove significant complexity from their implementations. But we hope over time folks will experiment with using these features directly in their applications now that React has made it possible to actually compose them nicely. You can find more information about React's HTML coordination features in our docs at react.dev. And if you want to learn more about how these features work, check out my talk this afternoon where I go into more detail about the problem and how we chose to solve it. Okay, before I wrap up, I want to share a quick update on hydration. In React 18, we launched a new selective hydration feature. And with this, React can hydrate parts of your application and prioritize components that have user interaction, like click events. However, as part of this release, hydration warnings became more prominent and were often frustrating to debug. Well, in React 19, we made two key improvements to hydration. First, React will now make extra DOM nodes in the body and the head. React will be more tolerant of extra DOM nodes in the body and the head, which will improve compatibility with third-party scripts and browser extensions. Thank you. I don't want to ruin the enthusiasm, but hydration errors are still going to happen, unfortunately. And for that, we've made some serious improvements to how we report these errors. Before, when a hydration error occurred, your console repeated the error multiple times, and the necessary information to debug the root cause was hard to find and often not very useful. Now, in React 19, hydration errors are consolidated into a single error report, and most crucially, they contain a diff of the props and the elements that are different. Now, look at this. All right, I hope you're as excited for these new features as I am. Here's Andrew to tell you more about actions and JSX. Thank you.
Good job. All right. Thanks, Josh. Hi, I'm Andrew, and I am also an engineer on the React team at Vercel. I've been working on React since 2016, and it was actually at that year's ReactConf that I somehow tricked them into letting me join the team, so I'm happy to be here again. So let's talk about some more improvements in React 19. The first one we're going to talk about is React Actions. Actions originally landed in the Canary channel last summer, and you may have heard about them in the context of something called Server Actions, a feature available in server components frameworks like Next.js. But actions are not exclusive to server components frameworks. They also work on the client, even if you don't use a server framework at all. So, what are actions? Actions are a first-class pattern for asynchronously updating data in your application in response to user input. Actions as a general pattern are not a React invention. They've been part of the web platform for decades. In fact, when HTML form actions were first introduced to the web back in the 1900s, JavaScript had not yet been created yet, if you can believe it. Form actions were the way to add interactivity to your web page. And in recent years, there's been a resurgence of actions-inspired APIs within the JavaScript community, thanks in large part to Remix, a React framework, Remix. A React framework whose web-centric and form-centric design has been greatly influential in reintroducing actions as a pattern for server-client communication. Nowadays, it seems nearly every JavaScript web framework has their own take on the actions pattern, and for good reason. We think that actions are a fantastic way to build applications, and they fit perfectly into the React programming model. But if action-based APIs already exist in React frameworks, why are we building them into React? We think we can take actions even further by integrating them directly into React features like streaming SSR, selective hydration, suspense, and transitions, all while maintaining React's obsessive insistence on composability. Our goal is to provide a core primitive that frameworks like Remix, Next, and Redwood can build on top of, the same way they currently build on features like streaming and suspense. To understand how actions in React work, let's go back to the beginning and look at form actions in HTML. So in a classic HTML form, you specify a server endpoint by passing its URL to the action property. When the user submits the form, the data is sent to the server, and the server responds with a fresh HTML page. So submit form, load page, submit form, load page. It's pretty simple, right? And what's great about this model is that you can use it to build almost anything. So why don't we? Because I've seen a ton of web apps, and almost none of them are built this way. Nowadays, a web developer could go their entire career without ever using this API. And what happened is, upon the introduction of JavaScript, we all love JavaScript, if it eventually became possible to build client-heavy web apps that provided a much richer, more interactive experience than apps whose behavior was confined solely to the server. Today, when a user opens your app, they have certain baseline expectations. They expect instant feedback when interacting with the app. There's no time to wait for an entirely new HTML document every time you click. And they expect apps to remember their current state. So you shouldn't lose your scroll position or your text input whenever you perform an action. In other words, users expect more than what's possible to achieve without at least some client-side interactivity. Because of this rise in user expectations, code written for the web went from looking like this to looking more like this. And there are some nice things about client-side event handlers. They can be used to implement instant, rich feedback to user input, and they can compose client and server behavior together. However, they also have some downsides. Managing local state asynchronously is super hard and frequently leads to bugs like race conditions. And because event handlers rely on JavaScript, the UI is not interactive until the code loads and runs, which is slow compared to raw HTML and leads to dropped interactions. So it's tempting to revert back to plain HTML actions. They have a very simple reload everything model that is super forgiving to all your application code, whether it's good or whether it's maybe a little bit sloppy. And they don't rely on JS, so the app is interactive as soon as the HTML renders. But we shouldn't forget about the reasons we moved away from actions in the first place. They provide little to no immediate feedback in response to user input. You're basically just stuck with whatever the browser stock controls give you. And it's really difficult to sprinkle on additional client interactivity because it's an entirely different programming model. React exists to solve exactly this kind of riddle. We've done it over and over and over again. How do we combine the structure and simplicity of server-driven apps with the rich interactivity of client-side apps, all within the same unified, composable programming model? So, how do React Actions achieve this? React Actions are an evolution of two existing APIs. The first is React Transitions, a powerful feature for updating state without blocking user input, introduced in React 18. Actions build on transitions by adding support for asynchronous functions. And the second, of course, is the HTML form API. Using a React action is a lot like using an HTML form action, except instead of passing a URL to the action prop, you can now pass a function. And in the most basic example, that's all you have to do. Pass a function to the action prop, and when the user submits the form, the action is called. By using an action function instead of a URL, you can define the behavior of the action directly inside your component. And now notice there's nothing special about an action function. They're regular functions. You can compose them, you can write abstractions for them, the same way you would any other function. You can define the action on the client, or if you use a server component framework, you can define the action on the server via the use server directive and access your data layer directly. You can have any number of actions per page, per component, per whatever. You can swap out actions at runtime. And we can achieve this level of maximum composability because we've integrated actions into every layer of React, from the client runtime to the streaming SSR renderer to the server component's data format, all working together to provide a seamless experience. You'll notice that in addition to looking a lot like HTML actions, actions also look pretty similar to event handlers like onSubmit or onClick. By convention, we use the word action when naming actions and the prefix on or handle when naming event handlers. Despite the surface level similarities, though, actions have some important abilities that set them apart from regular event handlers. One such ability is support for progressive enhancement. Form actions in React are interactive before hydration occurs. And believe it or not, this works with all actions, not just actions defined on the server. If the user interacts with a client action before it is finished hydrating, React will queue the action and replay as soon as it streams in. If the user interacts with a server action, we can go one step further. It immediately triggers a regular browser navigation, just like a classic web form. No hydration or JavaScript required. Yeah. Another area where actions really shine is in their handling of asynchronous logic. React actions have built-in support for UX patterns like optimistic UI and error handling. These are essential to building delightful user experiences, but they're notoriously difficult to implement correctly due to their asynchronous nature. Actions make these complex UX patterns super simple by deeply integrating with React features like suspense and transitions. With new hooks like use optimistic, use form status, and use action state, you can start implementing these patterns with just a few lines of code. Later today, we'll get an in-depth look at how to use the new action APIs to improve your app's experience. I'm really excited about those, so stick around. So that's actions in React 19. They're effortlessly composable. They have a unified client and server API. They're interactive before hydration, and you can implement advanced UX in just a few lines of code. So before we wrap up the React 19 portion of the keynote, I want to cover one more topic. Fair warning, this has nothing to do with actions or anything else in the rest of the keynote, but I think it's worth mentioning. React 19 includes a couple of changes to the JSX runtime, and most of them are related to everyone's favorite React feature, refs. Boo! Oh, okay, let's just wait. Well, I'm happy to announce that in React 19, ref is a prop. We did it! This took a lot of work. Okay, so on the surface, this is maybe an unremarkable change, but it in fact fixes a complaint that people have had about React for a while. Because in past versions of React, ref was not a prop. It had special behavior in the runtime. You could pass a ref to a component as if it were a prop, but in the receiving component, the ref would not appear in the props object. And as many of you are well aware, this made it difficult to create abstractions and components that accept a ref, which is a bit absurd given that React, as we all know, is all about composition. The historical reasons for why React treated refs this way are pretty boring. It's related to something called class components. I don't know if you've heard about that. So a few years ago, to solve the problem, without breaking existing behavior, we introduced a workaround API called forward ref. Boo! So mission accomplished, I think. Look, we all know you hate forward ref. It's cumbersome to write, doesn't play that nicely with TypeScript, and it shows up everywhere in your component tree. It's also just a little bit offensive, right? Why is something that should be so simple so complicated? It was the best way we knew to solve the problem at the time without introducing a breaking change. But today, we are finally making that change. Ref is now a regular prop. It appears in the props object, and that means you never need to use forward ref again. All right, that's the end of the conference. I think we can just end it there now. To make this happen, we are removing some long-deprecated APIs, including string refs and the legacy context API. We've been warning about these for a while, so most of you are probably unaffected. If you do have an older code base, we publish an upgrade guide with advice on how to gradually upgrade your components. So those are just some of the features and improvements coming to React 19. There's a lot more that we did not cover, but you can read all about those updates on our blog. And speaking of our blog, a few weeks ago, we announced the React 19 beta with a call for library and framework authors to test it out in preparation for a stable release. And so far, the feedback on the beta has been pretty good. So as a result, today, we are upgrading the beta to an RC, release candidate. That's right. That means we think it's stable enough for you to start trying React 19 in your applications. And pending any last-minute feedback, we expect a stable release of React 19 within the next few weeks. And with that, I'm going to hand it back over to Joe to talk about what's coming next in React. Thank you.
Awesome. Thanks, Andrew. We're really excited about the features in React 19, and we can't wait to see what you build. So forward ref, it's gone, finally. So speaking of APIs that are a compromise and that took us a while to get rid of, earlier in the presentation, we mentioned that our goal with React is to help developers achieve a great user experience. And a key part of that is near and dear to me, is performance. Now, developers are able to achieve great performance with React today. We hear this all the time. But it comes with a compromise, the need to do manual memoization. Now, sometimes in life, we all got to compromise, right? Got to eat your vegetables. But there's something so elegant about the code that we write with React. So rather than add yet another API or change the way developers have to write their code, we think that there's a better way to have great performance and a great developer experience. To show you what I mean, here's Satya.
Thanks, Joe. Hey, everyone. I'm Satya. Let's get started with the demo. So, yeah, we have a music player app here. We've got the now playing song and a playlist with a list of songs on the right. It's pretty snappy, right? I can drag this slider and there's no lag. React is actually pretty fast by default. But this is a high-end MacBook, right? Let's see how this app runs on a lower-end machine. I'm going to simulate that with the Chrome Performance Panel and do some throttling. OK, when I drag the slider, it's a bit choppy, but not really noticeable. Let's add this clock that my teammate Dan built. You may have seen it in one of his old talks. So green means everything's snappy. Yellow means we're slowing down, and red means we're in the slow lane. So let me drag the slider and see what it looks like. OK. There's some lag that we can see now with the clock. Let's debug why that's happening. So we've got the React DevTools. The React DevTools can highlight components that re-render by drawing boxes around them. Let's turn that on. All right. Now when we drag the slider, we see that the playlist is re-rendering. That doesn't seem right. Let's dig into the code to see what's happening. OK, so here's the music player component. We've got some initial state, and the state is being updated by the now playing component when I drag the slider. And that causes music player to re-render, which then causes the playlist to re-render. OK, I see the problem now. Luckily, there's a handy function that React gives us called memo. Let's use that. So we can wrap our playlist in memo and update the JSX. OK, going back to the demo, now we see that the performance issue is fixed. Playlist is no longer re-rendering, and the app is fast. Now imagine a number of engineers have worked on this app to make it fast and find all the optimization opportunities. And then a few weeks later, a new engineer comes along, and they want to update this component. We no longer want to display all songs, but filter a list of new songs. So they come in and update this to create a new list of filtered songs, and then pass that down as props. And when we go back to our app, the performance issue is back again. With one small change, we've lost all the optimization work that we've done. The problem is that filtered songs is being recreated on every render, which breaks our memoization. To fix this, we need to wrap this filtered songs in a use memo. And now, going back to our app, the performance issue is fixed once again. As you can see, performance is like a game of whack-a-mole. You have to constantly think about it. Also, looking at our component, there's a lot of memoization code here, distracting from all the product code. Right? We want to just see the actual business logic. Wouldn't it be great if we could automatically memorize our component and not have to do all this manual labor? Yes. Well, we've been working on a tool to do exactly that. Let me stop the server, delete all the memoization that I added, restart the server, but with the new tool that we just built. And going back to our app, there's no re-rendering of playlist. Our app is performant even without manual memoization. OK, but what if I add back the filtered songs? Does that break the memoization? So we can go back and update the component and then pass filtered songs as a prop, and going back to our app. And our app is still fast. So as you can see, you don't have to think about memoization again. You just focus on building your app, and the app is fast by default. To talk about this tool that I just showed you, let me invite Joe back on stage.
So you all have no idea what that possibly could have been now. You didn't see anything. It's still a surprise. Okay. It's all good. So we just ran a different command, and things got magically faster. That was React compiler, so you kind of figured that out, I guess. But it's React compiler. It's a tool we've been developing at Meta over the last few years. React Compiler automatically optimizes your components and hooks so that only the minimal parts of your UI update as state changes. So that seemed pretty magical. How could that possibly work? It's really not so scary, so let's walk through it. First, let me explain what I mean by compiler. We hear a lot about compilers these days to refer to all different kinds of tools that transform code ahead of time. There's been a lot of really great exploration in this space, and it's so exciting to see all the different approaches. React Compiler is more like TypeScript, or the compilers inside JavaScript engines like V8 or Hermes. It breaks your code down into individual expressions and builds up a control flow and data flow graph. It performs sophisticated optimizations, like dead code elimination, constant propagation, type inference even, alias analysis, and a whole bunch more. If you aren't familiar with these terms, that's OK. The whole point is React Compiler does that for you. These are optimizations that would typically appear, again, inside a JavaScript engine or compilers for languages like Rust or C++. With React Compiler, we're applying these ideas to improve performance without sacrificing developer experience. The code you write doesn't change. You saw that it was just the original React code right from that component. And our apps get faster by default. In particular, updates get faster by default. In fact, our code gets even more clean and concise because we don't need manual memoization. So that's what I mean by compiler, but what is it doing? How does it actually make that work? So let's go back to that media player example from earlier. This is a really concise, clear description of our UI logic. There's really nothing extra or unnecessary here. No use memo calls, no random unnecessary callback functions, just clean code describing the values we want to show in our UI. But there's a lot of information contained in this code that we might not always think about. For example, consider the filtered songs list. From reading the code, we know that filtered songs depends upon songs. Whenever songs changes, React is obviously going to have to filter that songs list again and update the playlist. This code also tells us the inverse. If songs doesn't change, then React shouldn't have to update the filtered songs, and it doesn't need to update the playlist. And as Satya showed, that's exactly what happens with the compiler enabled. We don't have to update the playlist when songs isn't changing. Now, we're able to understand this because JavaScript and React have clear rules for how they work. And we've learned those rules. We use them every day as we're reading code, writing code, debugging code, and occasionally testing code. We can also teach a compiler to understand those rules. The compiler sees this code very much the way that we do, except it's way more thorough, applying the same process to every value in our code, creating a computation graph of how your data moves through your UI. So this gives an idea of how React Compiler sees your code. But as I mentioned, the compiler knows the rules of React, and it knows some extra things. For example, it knows that set state functions don't actually change. So the compiler doesn't have to consider whether that value could update. So we can remove that dependency edge. So now we know that if setSong gets called and the song changes, from this graph we can clearly see the only thing we have to update is now playing, not the playlist. So this explains the behavior that we just saw in that demo. But the best part is that all this information comes from the same React components and hooks that you're already writing today. There's no API to learn. There's no need to change the way you write code. We can simply take advantage of all the information that's already right there in your code today. Some folks describe these type of precise UI updates as fine-grained reactivity, which I think is a pretty apt term to describe it. But as we've shown, we don't need anything new. All the information is already right there within your React code. Now, that all sounds great, and I know when I see a demo, I'm skeptical. Does it work in prod? Right? Well, I'm excited to share that we've been using React Compiler in production at Meta since early last year with exciting results. To tell you more, here's Mofe.
out React Compiler at Meta. So we're going to talk about how the compiler performs and pit it against apps at Meta. But first, we need to see what these apps even look like. Ooh, I got to update. Somebody did not update their operating system. Oh, I can't click away. I have to click update now. Ah, thank goodness there's a conflicting application running. We're back. Okay, but anyways, so we're going to talk about how these React compiler performs on these apps, but first we're going to need to talk about what they even look like. So let's first talk about their code. We noticed that React code at Meta can be mapped neatly onto 2 dimensions. On one axis, we have how fast or slow the app itself feels. How long does it take to repaint the page when I hover or click a button? On the other axis, we have readability. How concisely does the code describe business logic or what's shown on the screen? And just so we're on the same page, you want to be here. Fast interactions and easy to read. Now, a lot of the code that we see is in this quadrant. Most React code at Meta is pretty easy to reason about and also performs well. But on pages that have a lot of interactivity or just even a lot of components, for code that describes complex bits of UI, we find that developers start making trade-offs. Complex apps that haven't been optimized with use memo and use callback tended to be a bit slower but stayed easy to read. And a small sample of the code that we saw was pretty difficult to read. This code contained a lot of manual optimizations, which helped make the UI feel snappier, but they also made the code much more difficult to reason about. This is all a bit abstract, so let's take a look at one of these samples. So this is an actual, real React component from our code base. I had to rename some of the variables for legal reasons, but please trust me, some poor engineer at Meta actually needed to write all of this to describe their UI. And just to repeat, this is a single function, one component. We're not going to read any of this code, but I want to show you why it takes so many lines to describe this logic. Let's Control F to search for every call of use memo and use callback. Wow, that's almost 20 places where that developer hand-optimized an object. I also want to see how much of this code on the screen is spent just describing memoization. So let's also highlight the dependency array arguments. Oof. So all of the code in red that only exists to describe how to avoid recomputing values. And finally, I want to see how much of the business logic had to be wrapped and passed to use memo. This reflects how much cognitive overhead it takes to edit the core logic of this component. Oof. So now that we've kind of drawn this graph and written these axes, I'm going to tell you about the real meta apps represented here. This highlighted point we've been talking about, with the super long piece of code, that comes from a React Native app called Quest Store, the app store for Meta's Quest VR devices. Meta engineers spent a really long time hand-optimizing Quest Store because of how dynamic and interactive it is. For example, take the product details page, which I'm showing here. I've already bought Beat Saber, so I get a button that says download instead of purchase. And I can click or scroll with my headset controller through the left panel for different detail types, which might also differ across games. Now, you might also recognize another very dynamic, highly interactive React app built at Meta, and that's Instagram.com, a pretty complex website with a lot of hand optimizations. In 2023, we began rolling out React Compiler on both of these apps. Now, I originally had some boring stuff here, like how we resolved to roll out without rewriting any code, and how the compiler avoids cheating by removing memoization that developers wrote. But let's just get to the fun part and talk about some results. The rollout was a success. React Compiler has been enabled on Quest Store and all of Instagram.com as the default experience. Woo. So if you've browsed for any Quest apps or used any part of Instagram.com in the past couple of months, you've almost definitely been using React Compiler. In terms of performance, we measured that for some click and scroll interactions, the compiler-optimized version was more than twice as fast as before. We also saw initial load and cross-page navigation times improve by up to 12%. And finally, we observed that there was no impact on either memory usage or overall crashes, which may reflect out-of-memory errors. This improvement didn't apply to just a few pages either. We observed that Quest Store loads and navigations got faster by at least 4%, and Instagram saw an average 3% improvement across every route. At Meta, this was a really big deal. I mean, to put these numbers in context, engineers had combed through every single bit of these apps to add thousands of memoization calls. And of course, this work was done against metrics, which rewarded and the scale of every single optimization. On such an app, improving just a single thing, something like the time to first paint of a specific page, by just 1 or 2% would already be a huge deal. But React Compiler had significantly improved the performance of nearly every page it rolled out on. So how did the compiler do it? What did it do differently from all of these hardworking engineers? Let's take a look at that code from Quest Store again. Now I'm going to draw some white boxes to show places where React Compiler was able to add memoization that wasn't already there in source. We see that even on such a heavily optimized function, the compiler can still find additional opportunities for optimization. On less optimized apps, we found that React Compiler can add over 15 times the amount of memoization already present in source. The best part? Developers can now go back and delete all of this cruft without affecting the performance of their app. Yeah! So what this all means is that with React Compiler, developers will be able to get fast interactions on apps that haven't been manually optimized and improve the readability and maintainability of already optimized ones. In fact, we've just seen how React Compiler can even raise the ceiling for just how fast apps can be, as it can optimize much more than developers can with nested and conditional memoization, as well as sophisticated static analysis. Since proving out the core of the compiler last year, we've continued to roll out to even more apps to iterate on the compiler and, of course, the development, debugging, and testing experience. You may recognize some of these. To talk about what's next for the compiler, I'll hand you back to Joe.
Good job. So that's React Compiler. We will give you another update in 3 years. Let you know how it's going. So as Satya demonstrated, React Compiler allows developers to continue writing the exact same code you're used to. In fact, as we saw, we can stop using manual memoization, so get even more clean and concise code. And as Mofei shared, React Compiler can deliver significant performance improvements to real-world applications. That slide is blank. Rick changed the slides last minute, so thanks. No, it's good, it's good. I like it. Now, we've tested and shipped React Compiler at Meta. And at this point, we need your feedback to help get it ready for widespread adoption. So I'm excited to share that today, we are open sourcing React Compiler and publishing yes. I'm not gonna lie, 2 years building to this moment, it's been a lot of blood, sweat, and tears. Literally blood, like thinking about the compiler while going on a run, tripping, falling. Yeah, just like it's been a lot. So starting today, when you upgrade to React 19 RC, you can also install an experimental version of the compiler to get these same user experience wins without sacrificing developer experience. Installing the compiler is simple. There's a lot of complexity going on within the compiler, but to install it, it's just a Babel plugin. So install the Babel plugin. There's also an ESLint plugin that you can use, which will help to show if you have violations of some of the rules, like kind of an extended version of the current ESLint plugin. And again, just drop this into your Babel config. The compiler is definitely not done. This is an experimental release, so expect that there will be bugs or things that don't work. To help get the compiler ready for widespread adoption, we are also announcing that we're starting a React Compiler working group to collect high-signal feedback from a small group of early adopters. If you're interested in taking part, please see how to apply at the URL here. If you'd like to learn more about the compiler, we have 2 amazing talks scheduled. Later today, my teammate Lauren Tan will talk more about how to get started using the compiler in your app today. So if you're interested in trying out the compiler, highly recommend checking out Lauren's talk. And if you're a nerd like me and want to know how the compiler works, Mofe and Sathya will be talking about that tomorrow. It's a really approachable talk. I highly recommend checking that out to kind of get more of an idea of how the compiler is actually doing this magic. Last but not least, this has been an incredible journey. As I said, 2 years of a lot of work. I'd like to thank my amazing teammates, Lauren, Mofe, Sathya, Jason, Jan, he's here somewhere, and of course, Seth, who runs React at Meta. He helped to convince our leadership to fund this crazy effort and see the forest for the trees. That's it for now. Check it out, tell us what you think, and enjoy the conference.
There you go.